Hey guys, you're watching a new video on Logical Math channel. The jeweler sells large shiny diamonds whose price in dollars is proportional to the square of their weight. The price of a certain diamond is $60,690. As he couldn't sell it, the jeweler cut it perfectly so no weight is lost into two new diamonds, which total price is exactly $35,490. What is the positive difference in dollars between the prices of the two new diamonds? Pause the video if you want to figure it out for yourself and then keep on watching for a solution. Watch the video to the end for a bonus puzzle. Let's mark the weight of two new diamonds as B and C. Then the weight of the initial large diamond is B plus C. Denote the coefficient of price proportionality as K. Hence, according to the problem, the price of the initial diamond is K times B plus C squared, and the total price of two new diamonds is K times B squared plus C squared. So we have these two equations. And we need to find out the value of K times B squared minus C squared. In the left equation, we can replace the square of the sum with B squared plus 2 times BC plus C squared. Now let's subtract the right equation from the left one. On the left side of the expression, we can take K factor outside the parentheses. After that, B squared and C squared terms can be cancelled out. So we ended up with K times 2BC on the left. On the right side, we get 25,200. For now, place this equation aside. Next step is to square the right equation. After squaring, we have K squared times B to the fourth power plus 2 times B squared C squared plus C to the first power on the left side. Also, let's square the top equation. On the left side, we get K squared times 4B squared C squared. Then we need to subtract the second equation from the first one. On the left side of the expression, we can take K squared factor outside the parentheses and group B squared C squared terms. If you look carefully at the expression in the parentheses, you may notice that it is the square of the difference of B squared and C squared. Therefore, we can replace it with B squared minus C squared to the second power. As both factors are squared, it can be written in the next form. On the right side, we have the difference of squares. Hence, it is equal to the product of the sum of these numbers and the difference of these numbers. Following these, we get 10,290 times 60,690. And to get the value of the difference between the prices of the two new diamonds, we need to take a square root of both sides. The numbers on the right side are quite large, so it is not a good idea simply to get their product, as after that we need to take a square root. Instead of it, let's find out factors of these numbers. It is obvious that both numbers are multiples of 10. As there are two 10 factor, we can write it as 10 squared. Now check whether number 1029 is divisible by 3. We can use the divisibility rule for 3. If the sum of the digits of a number is divisible by 3, then the number is divisible by 3. The digit sum of the number is 12, so it is divisible by 3. The same holds for number 6069. 3 times 3 can be replaced with 3 squared. 333 is not divisible by 3, as the sum of digits is 10. The next prime number after 3 is 5, but as we can see the number is not a multiple of 5 as the large digit neither 0 nor 5. So let's move to the next one. It is 7. We can use divisibility rule for 7. To check whether a number is divisible by 7, we need to remove the last digit, double it, subtract it from the truncated original number, and if the obtained number is a multiple of 7, then the initial number is divisible by 7. For number 343, we have 34 minus 2 times 3 and it equals 28. 28 is a multiple of 7, so number 343 is divisible by 7. The remaining factor, 49, equals to 7 squared. We can collect 7 factors and get 7 to the power 3. Let's move on to the number 2023. It is not divisible by 3 as the digit sum is 7. Last digit neither 0 nor 5, so the number is not a multiple of 5. Checking for multiple of 7, we get 202 minus 2 times 3 and it's equal to 196. As it is not obvious that the number 196 is divisible by 7, we can apply the rule one more time for number 196. 19 minus 2 times 6 equals 7. So the number 196 is divisible by 7 as well as number 2023. One more factor 7 gives us 7 to the power 4 in total. The remaining factor 289 is equal to 17 squared. So now we can take a square root of both sides. To do this for the right side, the power for each factor should be divided by 2. Let's replace 7 squared back to 49. 3 times 17 gives us the product of 51. Then we can replace 49 with 50 minus 1 and 51 with 50 plus 1. Afterwards, instead of this product, the difference of squares can be written. 50 squared equals to 2500. Subtracting 1 gives us 2499. So the final result is 24,990. And that's the correct answer to the problem. Now it's time for the bonus puzzle. It is known that a plus b equals 6 and a squared plus b squared equals 20. What is the value of a minus b? Challenge yourself with this tricky problem and write your answer in the comments. Use algebraic identities to solve this puzzle. Thank you for watching the video. To support my channel, please subscribe, hit the bell button and give the video a big thumbs up.